Aristotle, the foremost Greek scientist, studied motion and classified it into two types: natural motion and violent motion. Natural motion on Earth was thought to be either straight up or straight down. Objects seek their natural resting places. Boulders stay on the ground, and smoke rises high in the air like the clouds. Heavy things fall, and very light things rise. For planets and stars, circular motion was natural. These motions were considered natural and not caused by forces. Violent motion, on the other hand, was imposed motion. It was a result of forces that pushed or pulled. The important thing about defining violent motion was that it had an external cause. Violent motion was imparted to objects. Objects in their natural resting places could not move by themselves. It was commonly thought for nearly 2,000 years that a force was responsible for an object moving against its nature. The state of objects was one of rest unless they were being pushed or pulled or moving toward their natural resting place. Most thinkers before the 1500s considered it obvious that Earth must be in its natural resting place. A force large enough to move the Earth was unthinkable. The astronomer Nicholas Copernicus formulated a theory of the moving Earth. This idea was extremely controversial at the time. People preferred to believe that the Earth was at the center of the universe. Copernicus worked on his ideas in secret. The first copy of his published work reached him on the day of his death, May 24, 1543. Copernicus proposed that the Earth moved around the Sun. Galileo. Galileo, the foremost scientist of late Renaissance Italy, was outspoken in his support of Copernicus. One of Galileo's great contributions to physics was demolishing the notion that a force is necessary to keep an object moving. Friction is the name given to the force that acts between materials that touch as they move past each other. Friction is caused by the irregularities in the surfaces of objects that are touching. Even very smooth surfaces have microscopic irregularities that obstruct motion. If friction were absent, a moving object would need no force to remain in motion. Galileo tested his idea by rolling balls along plane surfaces tilted up at different angles. A ball rolling down an inclined plane speeds up. A ball rolling up an inclined plane in a direction opposed by gravity slows down. A ball rolling on a smooth horizontal plane has almost constant velocity. Galileo stated that if friction were entirely absent, a ball moving horizontally would move forever. No push or pull would be required to keep it moving once it's set in motion. Galileo's conclusion was supported by another line of reasoning. He described two inclined planes facing each other. A ball released to roll down one plane would roll up the other to reach nearly the same height. The ball tended to attain the same height even when the second plane was longer and inclined at a smaller angle than the first plane. If the angle of incline of the second plane were reduced to zero so that the plane was perfectly horizontal, only friction would keep it from rolling forever. It was not the nature of the ball to come to rest, as Aristotle had claimed. Galileo stated that this tendency of a moving body to keep moving is natural, and that every material object resists change to its state of motion. The property of a body to resist changes to its state of motion is called inertia.